Hello and welcome back for another VMK in the puzzle series. In the previous VMK I showed you the 3x3 puzzle challenge, and I have also given you a VMK 1B which gives you the hint on how I solved the puzzle. Now I'm curious to know whether you guys approached the problem the same way that I did. I actually solved it two different ways, but what I'm going to be showing you is the second way that I ended up solving it. So let's jump right into our source code. In the previous VMK, I showed you the piece class structure and sort of described to you how I intended to use it. I've made some additional modifications to it, which I'll point out here right now. We have the piece class that contains the Boolean value that represents whether this current piece is being used or not. But I've also saved here this very important variable which tells me which way the piece is oriented, so which way is up. The number will basically range from 0 to 3 to indicate whether up is the top, whether up is the right side, whether up is the bottom side, or whether up is the left side of the actual piece. So this is a key important variable that we needed to know. Symbol, basically the same as what I described in the previous VMK. We have our symbol structure where we set the symbol using this guy. Our constructor will basically initialize to unknown, and a print function to print things out. I've also added this other member variable here, iid, and I've just done this so that when I print the solution I can quickly reference the solution with ID numbers and compare that to the actual pieces that I have laying on my desk. You don't really need this, but it just makes it easier to see whether you're getting the correct solution after multiple runs, or if you just want to pick pieces off your table and try to assemble them, this is a good way to do it. So because I've added this ID value, I've modified the constructor so that you need to pass in the ID number as the first parameter, and then we have top, right, bottom, and left, same as what I showed in the previous VMK. There's a print function which will print out the solution for this piece, and a test match function where we pass in a piece and its location. Finally, a get value function here. This is just a helper function when we're trying to solve for the matching cases to see whether these pieces match up together. Inside of the global space, I have choose center, check fit, find next, and show solution. So I'll talk about these here inside of the CPP file. Now the way that I've gone about to solve the problem is as follows. I said, okay, here's the 3x3 matrix that we're trying to find, and I've numbered each of these locations as shown here. So the center is 0, 1 is the very one above that, 2 is to the right of 1, 3 is below 2, 4 is below 3, 5 is to the left of 4, 6 is to the left of 5, 7 is above 6, and 8 is above 7. So because of this, I can basically now create an algorithm that will iterate through each of these indexes looking for matching pieces. And the way that this is going to work is we go down here inside of the main. We see I've initialized the 9 pieces that I have to work with. I go inside of this for loop, and basically grabbing each piece one at a time, I'm going to choose it to be the very center. So this function here, choose center, basically says I want to take piece number 0 to begin with to be the centerpiece. So I'm going to take this piece here, because this is index 0, and place it right here at the center. So that's where it's going to go inside of this array. Then once it's there, I'm going to call this function called find next, and I'm going to pass in the number 1, because I'm saying, okay, I know what this piece is. Now let's go and find a piece that goes right here at index 1, but this piece here has to mesh correctly with this index here. So that calculation will need to be performed. If I can't find any piece that fits here, then I'm going to go back to this guy and swap them out for a different piece. And then I'll repeat the process. So then I'll go here, see if I can find a piece. If I can, then I'll go, okay, let's move to the next one. So I'll go to number 2 and then try to find a piece that fits here that meshes with number 1. Repeat the process. If I can find one, then I'll go to the next step. So at step number 3, I need to then check, does it fit with 2, but also does it fit with 0, because there's 2 boundaries now that I have to be checking. So this is the sort of step-by-step algorithm that you'll be seeing me perform in this program. So that's basically it. We choose the center, we go and look for the next solution starting at index 1, and this function here is completely recursive, so it's going to keep trying to find the next one after 1, or try to go looking for 2, or try to go looking for 3, and so on. If it gets to the very end, meaning it finds the piece that fits in number 8, this function will return true, which will mean that we have a solution, so we can then call show solution, and that's just going to print out the results as I showed in the previous VMK. Once we print out the results, we return 0, we're done. If we can't find a solution, then we're going to go down here, print no solution found, and then return 1. So that's the main function, very simple. All it is one for loop that ends up calling this recursive function. So let's take a look at choose center first. Choose center is relatively easy. We specify which piece we want to place at the center. So we take that piece ID number and put it as the solution for the center piece at 0. Remember, we have 9 of them here, so 0, 1, 2, 3, 4, 5, 6, 7, 8 are indexed in this way. Then what I do is I go through a for loop from u is equal to 1 all the way to a value of less than 9. So in other words, I go through all the other pieces and I reset them back to -1. I do this specifically because as we're iterating through the recursive function, we may, go to a solution where we find one that fits here, we find one that fits here, we find one that fits here, but then we can't find anything that fits here. So we end up undoing all the way back to the beginning, which means that we want to undo all of these indices so that they're reset back to some initial value, which I've designated as -1. Also, when we're choosing the center, I go through here another for loop between 0 and 9, and for each one I reorganize the up position for each of those pieces. So up is designated as 0, and that's why you see me taking the member variable UI up and resetting it to 0. If the piece that I'm working with here is the piece that's located at the center, then I'm going to designate it to be true here for be used, because it is already used in the solution. It's located at the center. Whereas if it's any other piece, it's going to be set to false because I haven't used it yet. So choose center is really a reset function. Alright, so we've seen this. Now let's go take a look at find next. Find next, we pass in an index, which initially is the number 1, because that's the next value that we want to try to find that will mesh in correctly with the index located at 0. So once again, I'm looking for a piece that will go right here that matches up with the top part of the piece that's already located at the center here. So I'm just going to skip over this part. If the index is greater than 8, then we must have a solution, because this is a recursive function. So if we got that far, I'm just going to return true. Otherwise, I'm going to return false right at the very bottom, because we know that there's something fishy going on. Pieces are not meshing together. Alright, so inside of this function, I'm going through a for loop for every single piece. And as I'm going through every single piece, I have to make sure that the piece that I'm currently looking at has not been used already. Because this function is recursive, I'm going to be recalling it multiple times, and certain pieces may end up already being used. We know that the first piece, when the first time I call this function, is going to be 0, and 0 is already in the center, so there's no point in taking that center piece and trying to fit it in with itself. So we need to skip over that case. That's why we have that variable to keep track of things. So on the very first instance here, we're going to go take a look at piece number 1 and see that it's not used. So then we're going to go inside of the second for loop. And this second for loop is going to basically take the orientation into play here. So it's going to start off with the piece pointing upward. So up is a 0. And try to fit the piece into the current solution. If it doesn't fit, it's going to rotate the piece by 90 degrees, because we're just upping the up value here, which Well, going back here, we see that initially the up value will be at the top, then we rotate it 90 degrees, and that the right side will be located at the top. If that doesn't work, then we're going to rotate it again for the bottom side to be at the top, and so on. So as we're doing that, we're basically taking that orientation and applying it to the current piece that we're working with, and then checking to see whether it fits. And when I say checking to see whether it fits, I'm checking to see whether this index value, which is the value that I'm passing in here, and the current piece that I'm working with fit together. So let's take a look at this check fit function. It's just an algorithm that determines what it is that we need to check. We have 8 pieces here that we need to be checking for. We know that the centerpiece never rotates. It's just stationary, and we don't really need to check anything with itself. So the first one, if the index value is 1, we need to check the bottom of 1 and the top of 0. And that's exactly what you see here. We're taking the piece located at the solution of 0, so that's the centerpiece, and we're testing it to see whether it matches up with the piece that we are currently interested in, which is that index value that we passed in here. And the orientation that we're looking at here of this piece is the bottom. So the bottom of this needs to match up with the solution already in place at the center. If this returns true, then this function will end up returning true. If we're at piece number 2, then we need to check the left side here, which is what you see here. We take the solution at number 1 and comparing it with this current piece at the left side. For number 3, we need to be checking with the center and with piece number 2. So here we're going to return true if the center matches up with the left side of our current piece, and if the second piece up here matches up at the top. If we're at index number 4, which is this one here, we need to be checking with respect to 3 at the top. So that's what we see here. We take the piece at 3, testing it for the top of our current piece. At number 5, again, we have to check with the center as well as with piece number 4. So here we see we take the center, comparing it at the top, and number 4, comparing it at the right. For case number 6, that's this one here, we're only comparing it on the right side. So that's why we have checking with 5 on the right side. Number 7, we have to compare with the center as well and the bottom. So here we're checking with the center on the right and checking with piece number 6 at the bottom. And the final piece, we have to check not only with the bottom here, number 7, but also with the right side, number 1. And that's what we see here. We have number 7 on the bottom and number 1 on the right. And if for some reason we pass in an invalid number here, then we're going to default an error message saying invalid number. So that's pretty much the check to see whether pieces fit together. So the test match function, let's take a look at that. That's right here. For the piece, we're passing in a piece and the orientation or the location where we want to be checking this piece with respect to ourselves. So if we're at the location of the top, then we want to get the value of the bottom of ourselves and compare it with the top of the piece that we passed in. If we add those two values together and it equals 0, which is equal to fits, then that means that yes, these two pieces match up together. If we're looking on the right side, then we need to take the left side of our current piece and compare it with the right side of that other piece that we passed in and add those two together. If we're comparing the bottom, then we're looking at the top of ourselves with the bottom of the piece that we pass in. And if we're looking at the left, then we're obviously looking at the right side of us and comparing it with the left side of the piece that gets fits in. So each of these will return true or false depending on what the location value is. And it's going to return into this function, which will end up returning to tell us whether these pieces fit together. So that's all of that stuff up to here. We basically decide whether pieces fit or not. If a piece does fit together with the solution that's already in place, then we can say, okay, we know that this piece could be part of the solution. So we're going to mark it as true. Yes, we've used this piece. We're going to save it inside of the solution. And then we're going to go and find the next piece. In other words, we're going to recursively call this function to find the next solution that matches up with the now new solution that we've already stored inside of our vector. So I take the index that we passed in here, add 1 to it because, where's my reference diagram here? So initially we started at the center, we passed in 1. If we find 1, then we're going to take 1, add 1 to it, because now we want to find the solution at index 2. So that's all that that's doing. If this function returns false, then that means that something cannot work. We cannot find pieces of our puzzle that will fit together properly. So we need to undo what we just did. And what we did up here was basically mark the last piece as true, that we've used it, and told it that that's where the solution should be. So I undo that. I take the used piece here and mark it as false to say we're no longer using this, and undo that solution index as well to -1. So then we can rotate the piece and try it a different way, or increment it using this for loop to choose a different piece entirely. So that's basically it. Going down, what do I have left here? Oh, get value. Right, so get value here, we pass in what value we're trying to get out of this piece, and all it's doing is taking the orientation of our piece with respect to the location that we're looking at and returning the symbol that we're actually trying to see whether it matches up or not. So ignoring this, if we were to take two pieces and see whether they match up together, we would be basically saying, okay, what is the shape? So if we're looking at the top, which would be 0, and the bottom, which would be 3 of a certain piece, then we'd get the shape value returned to us. So it would be something like heart out and maybe club in. So we take -4 and add it together with +2, and we see that the result is -2. Therefore, those two pieces don't fit together. So if we had -4 and +4, then those two pieces would fit together, so the result would be fits. It would be 0, therefore it does fit together. Now the difficult thing here is that each piece can be rotated, so we need to take that into consideration when we're trying to pick off which shape that we're actually playing with inside of our piece. By default, all of our pieces are always saved in the orientation so that 0 is up, 1 is to the right, 2 is down, and 3 is to the left. But because the pieces can be rotated, we do have this up value. And when we're calculating the location here, we have to take that into consideration. So we take the location and add the up value. That's going to give us a new value. And that index value could be greater than 4. What we can do is just subtract 4 from it, because we know it's only ever going to go between 0 and 4, and that will actually end up giving you the correct symbol that you want for the piece. So that does the math for you and returns to you the symbol ID of the piece that you're looking at the location that you're trying to look at. Oh, there's the constructor for the piece. So here we're passing in the ID, top, right, bottom, and left. The ID value is just passed into the ID value. Use is set to false, and up is always initialized to 0. And then top, right, bottom, and left, we call the set symbol function to pass in the top, right, bottom, and left symbols that were passed into the constructor of our piece. And well, let's take a look at the shape constructor. Our shape constructor, when we construct a shape, just initializes the symbol to unknown, but then when we call set symbol, we are basically setting the symbol value into the value that we want to save. That only leaves print, which we call from our show solution. So for each piece that we have, we call the print function, which we see right here. And all it's going to do is display the ID value and then in brackets the orientation for the top, right, bottom, and left sides of that piece, and then also indicate which of those are actually pointing upward. And we can get that by taking the shapes up index and printing the result. So each of these shapes have a print function, which I have displayed here, and it's very simple. It just takes the symbol value and returns a text readable string to let you know which orientation this shape is in. So if it's heart out, it's just going to display heart out, spade out, and so on and so forth. So I think that's it. I've gone through all the functions. Now if we run this through, Control F9, we can see here's the solution. So if I were to take the pieces that I have here defined and lay them on my desk so that the first piece is this one here that has spade out, heart in, diamond in. The next one, second one, spade out, heart in, club in, and so on and so forth. And then if I look at the solution, then by taking the ninth piece, the fourth piece, the second, seventh, third, sixth, first, fifth, and eighth, they should be able to snap in together. So let's give this a try and see whether it works. Okay, so here we are back. Now let's take a look to see whether the solution actually works. In the main function, I basically laid everything out from 1 to 9. So what I need to do here now is take each of these pieces and order them in the same order. So let's see, here we have heart, diamond, diamond, heart. That was heart, diamond, diamond, heart. That was number 7. So I'm going to put it here beside number 7. Then we have spade, diamond, spade, heart. That was number 3, I believe. Then we have club, heart, spade, heart. Club, heart, I think that was number 9. Then we have spade, spade, heart, club. That's number 2. Then we have diamond, club, club, diamond. That was number 4. Next is heart, club, or sorry, heart, spade, spade, club. Heart, spade, spade, club was number 6. I have spade, diamond, heart, diamond. Spade, diamond, heart, diamond. That was number 1. Heart, diamond, club, club. I think that's number 8. And finally the last one, club, heart, diamond, club, which was number 5. Alright, so now that we have all the pieces, let's arrange them in the order that the solution was presented to us. So the order was 9, 4, 2, 7, 3, 6, 1, 5, 8. So let's see whether that works. 9 was in the middle. 4 was up above. 2 was to the right of that. 7 was below that. 3 was next. 6 was the next one. 1. 5. And finally 8. So there we have it. We've basically assembled the 3x3 puzzle with the use of the computer.